Hello, my name is Dan Griffiths. I'm a geologist and technical director for groundwater restoration with Parsons in Denver, and I'm the supervising contractor at the Lowry landfill site. I prepared this presentation and I'm familiar with its content and the site in general. In this presentation, I'll provide a brief overview of the first half 2022 Remedial Action and Operations and Maintenance Status Report, known as the Site Status Report or the SSR. This report contains site operational data and activities that occurred between January 1st and June 31st, 2022. First, some background information. The Lowry Landfill Superfund Site is located northeast of the intersection of South Gun Club Road and East Quincy Avenue. Lowry is bordered on the north, northeast, and east sides by the currently operating Denver Arapahoe disposal site. The map on this slide shows the location of Lowry Landfill in relation to surrounding roads and site features. Here we have a general timeline of the Lowry Landfill Superfund Site and its journey through the CERCLA Superfund Site process. Lowry Landfill was added to the National Priorities List in 1984 and was closed in 1990. After closure, the Record of Decision was issued in 1994, and the remedial design and implementation, which included the installation of all the remedial components we'll talk about in the following slides, continued through 2006. Remedial construction was completed in 2006, and the site transitioned to remedy operations and maintenance at that time. The site has been in operations and maintenance and long-term monitoring since 2006 and will remain at this status for the foreseeable future. Since remedial construction was completed in 2006, site activities has focused on the operation and maintenance of the site remedial components, monitoring to ensure that the remedial components continue to operate correctly, and periodic reviews to ensure that the site remedy continues to be protective of people and the environment. The most recent 5-year review, finalized in January of 2022, found that the site remedy continues to be protective of human health and the environment. Lowry Landfill was divided into 6 operable units during the remedial investigation phase, and this division was preserved through the remedy design and implementation process. Operable units, or OUs, at Lowry include OU1, shallow groundwater and subsurface liquids, OU2, landfill solids, or solid materials disposed of in the landfill, OU3, landfill gas, OU4, which is natural soils beneath the landfill, OU5, which is stormwater and sediment in the ditches, and OU6, which is deep groundwater beneath the landfill. Each of these operable units were characterized during the RI, and in some cases during follow-on work after the RI. Each OU is remedied and monitored routinely. The Lowry landfill remedy is a containment remedy, wherein the waste materials that were disposed of at the landfill during operation remain in place at the landfill and are contained by a series of remedial components so that they don't migrate out of the landfill. Containment is US EPA's presumptive remedy for municipal waste landfill Superfund sites nationwide and is not unique to Lowry. The remedial components all work together to make up the containment remedy at the Lowry landfill and consist of the landfill cap, groundwater and leachate control, which is accomplished by subsurface barriers and pumping, the on-site treatment plant to treat water that's pumped out of the pumping systems, and the landfill gas collection system, also institutional controls. All of these remedial components are operated and maintained on a daily basis by a team of dedicated people on site. The operations and maintenance activities conducted on site are documented in the site status reports. These site status reports, or SSRs, are prepared every 6 months on behalf of the work settling defendants, pursuant to subsection 2.1 of the consent decree statement of work. The SSR presented here is the most recent SSR in a long line of SSR documents dating back to 2006. The SSRs are publicly available documents that can be downloaded on demand from websites maintained by EPA, CDPHE, and Lowry Landfill. Simply Google Lowry Landfill and you'll be taken to these websites where SSRs and all other documentation regarding the site can be accessed. The current SSR summarizes all operations and maintenance activities completed between January 1st and June 30th, 2022. During the first half of 2022, operations and maintenance activities were conducted in association with the site water treatment plant, groundwater remedial action components, stormwater, landfill gas collection, and the landfill cover. No remedial action activities were performed during this reporting period. All activities were conducted in accordance with operations and maintenance manuals. All operations and maintenance activities were conducted in accordance with 7 site plans listed here, which govern and guide all of the activities on site. We also have a separate series of plans defining monitoring activities that occur north or down gradient of the site. We call this the north end. This slide presents key areas of the SSR that are summarized in the executive summary of the SSR document and are presented in detail in the body of the SSR. And I'll use this as a guide for the rest of this presentation. We'll focus briefly on each subject area, starting with the 5-year review. The 5th 5-year review document was finalized during this SSR reporting period. Ultimately, it was signed in January of 2022. The 5th 5-year review and all of the supporting studies completed leading up to the 5th 5-year review found that the remedy at the Lowry landfill is protective of human health and the environment at and around the Lowry landfill site. The remedy at Lowry is a containment remedy, so protective means that the waste at the Lowry landfill is contained and poses no unacceptable risk to the environment and the surrounding community. This slide presents a list of groundwater remedial components that are evaluated in each SSR, as well as voluntary actions. Essentially, we look at each remedial component to determine if that component is working as it should and is meeting its objectives. The sum of all these evaluations adds up to the determination that the remedy as a whole is working as it's supposed to. At this point in the presentation, we will focus on the operations and monitoring activities that were conducted during the SSR reporting period, again between January and June of 2022. During this time frame, the slurry wall, which is a vertical barrier that prevents groundwater flow and encompasses the site on the west, south, and east sides, continued to contain chemicals inside of the landfill itself. The north toe extraction system, which is located in the center of the site, continues to capture impacted groundwater flowing from the landfill toe. The north boundary barrier wall, which is at the north end of the site, continues to remove about 6 to 10 gallons per minute of groundwater and is preventing contaminants from migrating off-site through this area. Groundwater extraction in the MW38 area captures contaminated groundwater flowing through this area and prevents off-site migration. And finally, vertical migration monitoring continued to show that contaminated groundwater has not migrated downward to deeper aquifers beneath the Lowry landfill itself. At Lowry, more than 500 wells distributed on-site and off-site are routinely inspected and monitored to track remedy progress, and 7 active pumping systems are operating around the site to maintain groundwater capture. The 7 pumping systems are shown on this map to the right, along with the slurry wall shown as the red line going around the southwest, south, and southeast sides of the Lowry landfill. Data collected during the reporting period shows that the monitoring system continues to be effective and the inward direction of groundwater flow is maintained, which means that contaminants within the Lowry landfill itself can't migrate outside of the landfill footprint. Within the 500 or so monitoring wells on site, 60 wells are located in key areas and have been identified as compliance wells. Sampling at these 60 wells is conducted quarterly for 29 different indicator chemicals to monitor the performance of the groundwater remedy. During the reporting period, 53 wells were in compliance in that concentrations of all indicator chemicals were below performance standards. 7 wells were out of compliance or potentially out of compliance, as indicated by the red dots on the map to the right. Additional response actions in the form of supplemental groundwater pumping continues at all 7 well locations in accordance with the groundwater monitoring plan to control or eliminate groundwater flow in these areas. The reasons for these out of compliance cases are well understood and have been documented in other documents historically and most recently in the effectiveness evaluations published in 2021 as part of the 5-year review process. During the reporting period and historically as reported in previous SSRs, public health is protected at and around the Lowry landfill. In most cases, compliance wells are in compliance, and in cases where compliance wells are out of compliance, groundwater flow is controlled through pumping. The impacted shallow groundwater is not being used, and people in the environment are not being exposed. There are several areas that we wanted to focus on briefly during this presentation and that are presented in detail in the SSR. In this slide, I'm focusing on the North Toe Extraction System, which is located in the approximate center of the Lowry landfill site. This system consists of a cutoff trench and groundwater extraction to capture groundwater flowing from the toe of the landfill. The performance indicator that is used to determine if this system is meeting its objectives is that the water table in the trench is maintained below the bottom of alluvium, thus capturing all groundwater flowing through this area. During the reporting period, the water level in the trench was maintained on average 6 to 8 feet below the bottom of alluvium. And as you can see on the map, in the top right side of this slide, groundwater flow is toward the trench and groundwater flow in this area is captured. Thus, the North Toe Extraction System operated as designed during the reporting period from January to June of 2022, and the system met its objectives. In this slide, we're taking a look at the north boundary barrier wall area located on the north side of Lowry. We've talked about this area many times during past public meetings, as this area is a key component to the groundwater containment remedy. The map on this slide is from January 2021, and I included it to illustrate that this groundwater pumping in this area over 1 year between January 2021 and January 2022 has significantly reduced groundwater flow in this area and improved containment and capture. On this map, the north boundary barrier wall is shown as the green hatched polygon, and the pumping wells around the north boundary barrier wall are shown as purple dots. The blue lines on this map are groundwater potentiometric surface contour lines that depict the shape of the water table in this area. As in past maps of this area, there are low spots around pumping wells. The red arrows you see show the direction of groundwater flow, and the yellow shaded area is the area of containment that is maintained by groundwater pumping. Any contaminants in this area of containment are contained and will eventually be removed by the pumping wells. This map is figure 416 in the SSR, and I invite anyone that is interested to take a look at the SSR for more detail on this area. In this slide, you see the same figure from January 2022, or 1 year later. In comparing the two maps, you can see that the dry areas, or areas where no groundwater is remaining, as defined by the crosshatch pattern, have expanded significantly. Groundwater flow is not flowing through these areas, and containment is further improved. Between January 2021 and January 2022, the areas of dryness or no groundwater have expanded significantly, indicating that the area of containment has also increased and the potential for groundwater flow through these areas has decreased. On this slide, you see the MW38 sand channel area located in the northwest corner of the site. Much like the last slide, the blue lines are potentiometric surface contours that depict the shape of the water table in this area. Extraction wells are shown as red dots, and the compliance well in this area is shown as the blue dot. The blue arrow is pointing to the compliance well, and the data shown in the chart to the left is from the compliance well. As you can see, groundwater flow is inward toward the sand channel depicted in purple, which is the primary objective of the MW38 pumping system. The chart on the left side of the slide shows contaminant concentrations, in this case 1,4-dioxane, that were measured in groundwater at the compliance well. And as you can see, 1,4-dioxane concentrations continue to decline. The time scale is shown at about 16 years, and as in the case of the previous slide, the graphics on this slide are directly from the SSR. And if you're interested in more detail or more context, you're welcome to review the SSR document, where you'll find these figures as well as text describing and explaining what's in these figures. And the final groundwater remedial component we wanted to highlight is the north end response action pumping. This is the groundwater extraction that occurs in the Weather-Dawson water table aquifer north of the north boundary barrier wall that we looked at a couple slides ago and south of Yale. So on the map you see on the right-hand side of this slide, the top of the map is Yale and the bottom is the north boundary barrier wall. There are 5 pumping areas, 16 extraction wells, and a series of monitoring wells in this area. And groundwater samples are collected quarterly to monitor groundwater quality. And on this slide, we have depicted 1,4-dioxane concentrations in groundwater north of Yale and south of Mississippi. The response action objectives for the pumping south of Yale is to remove 1,4-dioxane mass from the plume, which has been achieved during the reporting period, as shown, with about 6.5 million gallons of shallow groundwater extracted and about a pound of 1,4-dioxane removed. In addition, groundwater monitoring in the north end continues to document declining 1,4-dioxane concentrations as reported in the SSR. The data plotted on this map is an example of data plots available in the SSR. They're there to show 1,4-dioxane concentration trends over time, which are all downward, meaning that the 1,4-dioxane concentrations are going down and water quality is improving. If anyone's interested in digging into this further, all of the information, the map, and all of the plots are available in the SSR. During the reporting period, and historically, as reported in previous SSRs, public health is protected north of the Lowry landfill. The groundwater in the shallow groundwater plume north of the site is not being used. There are no drinking water or agricultural wells in the plume, and the plume is getting smaller over time. People and the environment are not being exposed to the remaining contaminants in the north end plume as the plume is gradually being remediated. And to complete the groundwater story at Lowry, we have some information on the treatment plant itself. The treatment plant receives and treats groundwater pumped from the groundwater pumping remedy components we have already discussed in the previous slides. During the reporting period, we treated approximately 1.5 million gallons of water using the biological treatment system and advanced oxidation. The combination of the two systems destroys more than 92% of the incoming contaminants, and the discharged water is discharged to the Metro sewer system in compliance with our discharge standards. We have a third system, the ion exchange system, that we installed in 2021 that removes about 99% of the molybdenum from water coming into the plant. After the treated water is discharged, it goes to Metro's wastewater treatment plant for further treatment before eventual discharge to surface water. The on-site plant removes or destroys all site chemicals to meet safe standards before the water leaves the site, and the treatment process we use leaves minimal environmental footprint. Now let's depart from groundwater and talk briefly about the other remedial components that are maintained and operated on site. First, we have the landfill gas collection system. The waste at the landfill is covered and contained, so gases generated during the degradation of this contained waste need to be extracted and collected to maintain containment. The gas system consists of 64 gas extraction wells, condensate traps, piping, 2 flares, and the gas to energy plant. This system removes about 5,000 tons of methane each year and produces enough electricity to supply power to about 2,500 homes in the area. During the reporting period, this system was maintained and operated with no issues identified. More information on the gas collection system is presented in Appendix D of the SSR document. As mentioned in the previous slide, the landfill is covered with a layer of compacted clay and soil that ranges from thickness from about 4 to 12 feet. This cover reduces the infiltration of rain and snow melt into the landfill, and it minimizes potential for groundwater impacts, in addition to containing landfill gas so that it can be extracted and contained. During the course of the reporting period, the cover was routinely monitored to look for settlement or any other issues, and between January and June of last year, no cover issues were identified. And the last remedial component is stormwater. During the first half of 2022, there were no storm events big enough to get stormwater to flow on site, so stormwater samples were not collected. This commonly happens during dry conditions and has become the norm over the last several years. During the next reporting period, July through December of 2022, stormwater ditches will continue to be monitored. This and historical Lowry Landfill SSR documents can be found on 3 different websites listed on this slide, or simply by Googling Lowry Landfill, and you'll be taken directly to these websites where SSRs and all other information regarding the site can be accessed. If you have any questions or you want additional information that can't be found in the various site documents, please address your questions to the US EPA Community Involvement Coordinator, Meg Broughton, at the email address on this slide. And this concludes this presentation on the Lowry Landfill first half of 2022 SSR. I hope you enjoyed this presentation and you'll take a look at the SSR document to learn more about Lowry Landfill. Thank you.